Hello, Flat Earth researchers, debaters and debunkers.
Surprise! Not quite the opening you are used to, right? Well, I've seen a couple of videos on YouTube today by Bob the Science Guy and Where's Wally debunking Phuket word here. But as good as they were, I feel I need to do it on my own way with my own experiments and my own observations. So, yeah, let's go.
I thought it would be worth just demonstrating how unscientific and how easy it is to show how the people that believe they can disprove the flat Earth and prove a globe Earth with these water level experiments.
Really? Really? Really?
Are really just being very childish and unscientific about the whole thing. It's so easy once you see what's actually going on here to demonstrate how wrong they are and how they just don't have anything but lies and obfuscation on their side to try and debunk this idea that the horizon somehow drops below eye level. The fact is that eye level is where you will always find the horizon. This is a commonly accepted fact of life.
No, Phuket word. It's not a common fact of life. It's a common fact among flat earthers. The rest of us is rarely aware of the horizon drops. And I'm going to show that later.
Until you come across someone who wants to defend the globe belief. And of course, the globe model is very much dependent on having a horizon that's created by some kind of imaginary curvature, when in fact the horizon is something that occurs in our eyes as a result of looking across a level surface.
It's what's happening in our eyes looking over a flat surface. Well, that's not how light works. The light shines off the ships here and is reflected over the curvature. And we cannot bend these photons with either a P1000 or our eyes. So our eyes or a camera cannot determine what's happening here. Can't decide what's happening here. We can only observe it. We cannot affect it in any way. So it's not in our eyes. It's out there.
So let's just go through this and we'll show very clearly why these guys just can't really do any science at all. And they have nothing to back up their ridiculous claims that we have this kind of apparent drop in the horizon at eye level.
Wanna bet on that?
So here we have this introduction here that says, flat earthers like to say water finds its own level. Well, this is just simply a fact of life, and this is why you can use the water level as is demonstrated here, because we know that water on either side of these tubes will be at the same level. This is real physics.
Well, at least we agree on something. Water will always find its level. So, yeah, agree on that one.
And this is why we know that when we look at we compare these two diagrams here of a flat Earth model, which is more like reality, and this ridiculous round Earth globe model, we can see that, of course, the natural physics of water would have water flow down this curve.
Seem to forget one thing, Phuket word. This curved line here is the surface of the Earth, and we have something called gravity, which pulls this evenly in towards the center of the Earth. So this is not downhill. This is just south or west or some other direction. This is down, so the water doesn't flow that way. It gets pulled this way, downwards, by the gravity. Like it or not, we have gravity.
And on a level plane, it would be much more easily contained between these 2 points. I mean, straight off, this is just physics. This is just real life physics. But that aside, what we're talking about here is how these measurements are performed by using this kind of spirit or water level to find what they call true level. And we can see that what we're talking about here is eye level. So we have the horizontal eye level line of sight at this particular height, lined up with these water levels here, and seeing if it will line up with the distant horizon. That's basically the premise of the experiments here. And here is what they predict is what you should see on a flat Earth. Basically, this is eye level passing through the 2 levels here, and you would also see it hitting a mountain in the distance. And of course, with the globe Earth, you would have this eye level horizon that shows this massive drop of more distant objects.
Okay, so this is where my observations come in play again. You have seen them before, but let's just go quickly through them. So my eye level is about 70 feet, 22 meters above water. And when I shoot across that water level, I have the line across the lighthouse. And below that line, over here, we have those wind turbines. So that's how you do observations with the eye level. And again, you've seen this before, but let's just see what Phuket would have to say about this one.
Well, of course, to go with this, you have some mathematics.
As maths of this kind is not my strong side, I'm just going to jump over it. I'll leave this to someone else.
So here's what they've done. We've got some photographs here showing this water level here, which does, in this instance, line up with the more distant horizon. And we have all this maths to go with it. And here they say this experiment actually works out at sea level. Sea level is just a hair below true level.
Well, yeah, of course. When you're standing just over the water, the horizon will be just above water. It's not a big gap. It's just where it is.
But what do you actually consider you are looking at? Do you think you are looking into this bulge of curvature that's coming up to the same physical height as the water in front of you? Well, obviously not, according to this illustration here, where you have a surface which at least is correct in this assumption that you would have a surface that's always curving down and away from you. So, you have to consider what is it that makes this horizon appear to be as high physically as the water in front of you, because we know that physically it's not doing that. This is the effect we have when we look across a flat surface.
Well, it doesn't rise to eye level, but in your picture it's damn close, because that's just above the surface of the water. I'm standing at 70 feet, and it's a bigger gap, and the higher you go, the bigger the gap.
But we'll see in a minute that this whole setup isn't at true eye level. And we have a similar thing here. So what we have here is this claim that in this experiment it works out in the mountains at an altitude of almost 2 miles above sea level. The horizon is over a degree below true level. So we have these mountains and the elevation, and then we have this peak in the distance, and we have this line here representing true level. Well, okay, you can see that this is lined up with these water levels here, but is that really the same as the eye level, as was illustrated in the diagram up here? You know, is this apparatus lined up with eye level to represent true level, or is there some confusion there over, or obfuscation over what eye level and true level actually are? Well, we'll see again how that has been misrepresented in this photograph.
This will be, what you call it, interesting.
And some more explanations here, an illustration of the setup, and again we have this line here that's been put across this photograph to represent level. So we have, or what they might refer to as true level, but is this eye level?
Yes, it is.
Again, we'll have a look and see whether or not that is actually eye level. So,
excuse me?
But first, let's just reiterate what eye level actually is. And this is according to any kind of dictionary definition. Eye level is a horizontal line of sight. So yes, you can talk about the height of the observer being that person's eye level, but what is most important is that person is looking straight ahead, a horizontal line of sight. That is eye level.
Again, I agree with you.
Now, of course, if you have something that's physically at eye level in front of you, such as a photograph, a picture on the wall, or an eye level grill or something like that, then physically that object is at the same height as your eyes and you're looking straight ahead at it. But when it comes to the horizon, this is obviously something that's off into the distance, and this is just a natural, observable, visual phenomenon that happens when we look across a level surface. We have this surface appearing to rise up to eye level, and it is at this point of convergence is where we get our horizon. Again, this is not something that's ever contested by anyone. This is a widely accepted fact of life, that when we look straight ahead, we will see a horizon at eye level. There is no argument about how high off the ground we are. You look straight ahead and you will have a horizon at eye level.
No, you will not. That's wrong.
And just to be very, very clear here, if we kind of looked up slightly or looked down slightly, we could be tilting our head or even our eyes. Again, we've got to remember that the eyes can move about in their sockets, and of course even a slight movement from true level, eye level, will obviously result in this widening gap, because obviously it gets longer and farther apart over distance, and the same goes for looking down as well.
That's exactly what it is, because horizontal is probably just above the horizon here, but there's nothing to look at, so your eyes are drawn that little degree, or the fraction of the degree down here to the horizon, because that's where it's something to look at. That's the point of interest to our eyes. Horizontal, maybe just a fraction of a degree above here, but it's nothing to look at. That's just as simple as it is.
But of course we also have perspective, which comes into play, which works in the opposite way to the widening field of view, where we have perspective creating a shrinkage in angular size of everything in the distance.
And there we have it. Perspective. Of course. Perspective makes stuff shrink at distance. So, Phuket word, just how far away do I need to push that wind turbine to end up below my eye level? Because that's what happened on my observations.
All right, but that's basically it. Anything that's up or down from eye level is not eye level, okay? Eye level is only this horizontal line of sight. All right, it really shouldn't have to be explained. This is just a fact of life. So let's go back to the first photograph, and we can see here that one really easy way to do this, for if anyone wants to look at these websites and believe the claims that they are making, then you just go ahead and you believe it, but the whole point here is to test these things for yourself.
I did.
So what you can do is just take any of these photographs, and we can see here, for example, that this one is 600 pixels high from top to bottom. So all we have to do to establish eye level, assuming that the camera was horizontal, and this was obviously being scientifically done, then we should have everything lining up midway.
Assuming the camera is level. And you call your stuff here for scientifically? Seriously?
What I've done here is I've just brought this marker down. We can see that it comes down to exactly the 300 mark there, so that's exactly halfway. This should be eye level of this photograph. It should have been taken horizontally if this experiment was going to be in any way truly scientific.
I really hate to let you down, Phuket Word, but you're wrong. You see here, this is pretty much horizontally. If you see the wind turbines back here, they line up with that house pretty well. And it really doesn't matter if it's up here, down here, or that way, up here, or down there. Or this way, here, down here. It doesn't matter. There's no internal movement of anything here. Everything stays in the same place. So where you point the camera has absolutely nothing to say with what you see. Nothing.
And represent eye level or true level, if you like. But what do we have here? We have this eye level which is way above both of these.
I'm not going to go too deep into this here, but just gonna throw in the link to this video in the description. But Phuket Word, it really doesn't matter where you point that camera as long as you have a water level. Eye level will always be eye level across that water level. There's just no way getting around that. If you have eye level bottom screen or eye level top screen, it doesn't matter. Eye level is across that water level, whatever. Go watch my video and please debunk it.
So okay, this person has managed to photograph the water level and put it in line with the horizon, which is easy enough to do if you just play around with the camera and the parallax. Then you'll eventually get this result. But what you should also do is make sure that everything is lined up here at eye level, and when it is lined up, then you know that actually this will tell you that the camera is in fact level. So you can see here that this hasn't been done properly. All right. Again,
Phuket Word, I hate to break it to you, but you're the one not doing it properly. The way you're doing it with the water level is just perfect. You don't need to have the camera center frame.
And the same goes for the next picture here. This again is a height of 600 pixels, and we can see here that they drew this line here to represent what they called true level. But if we bring this marker down again to the halfway mark, to 300, we can see that the camera's eye level is here. Okay, this is the center of the camera's field of view, and it's way below these two levels here. So none of this is lined up properly. This hasn't been scientifically done.
So now all of a sudden eye level is center frame. Okay, let's see how that works in this photo. In Paint you have this little marker here. It marks halfway up and down. So if I draw a line here, just about there, That's eye level. I don't think so.
And so this line, this white line that they put in here, means nothing. It means absolutely nothing because the camera's eye level is here. And again, it's worth pointing out that if you're going to talk about eye level, then if you have a photograph, then it is the center of that camera's field of view, as long as that camera is looking straight ahead, horizontal line of sight.
As long as the camera is level, eye level is always center frame. You don't need to explain that. That's just normal logic. That's common sense. Level camera, level water level, eye level is center frame. But as I showed before, you don't need to have a camera level to have center frame inside a picture. Eye level is not center frame here. As long as you have the water level here, eye level is not center frame here. Eye level is still up here. This is just how it is. This is photography 101. Learn how the camera works. This is basic knowledge.
You can't then draw lines elsewhere and make claims about where eye level should be, because eye level is always subjective. It's not objective. It's always subjective.
Then may I suggest you go out and try this for yourself. This is my experiment, my observation, my photos. That's me. So if you just try this for yourself and see what happens. Please.
Your eye level is different depending on where you're standing to someone else next to you. But everyone has a horizon that's at their own eye level, wherever they are looking, however high or low they are off the ground or above sea level. Each individual observer has their own eye level, and they have their own horizon at their own eye level. So you simply cannot dictate where eye level is for anyone else other than for the observer. So again, this is wrong. And we look at this one. Again, here we have this line that they've drawn to represent what they called true level. This particular image is 651 pixels. So let's just, for the people who have difficulty with numbers, let's just, sorry, let's go back. So 651, all we've got to do here is go 651 divided by 2, and that gives us 325.5. So we just bring this up. We'll go to 330, oh, that's 325. Okay, so what do we have here? We have this level here, eye level of the camera, which is above these levels here, and again, it's just an unscientific observation. It hasn't been done with any degree of accuracy. It's not representing eye level or true level in any way. It's wrong. And even we go to the photograph that was said to inspire this whole thing. I've already put the marker here. You can go and test it for yourself. This was 440 pixels high, so 220. We have the camera's eye level if it's looking straight ahead, and we can see it's not in line with these two water levels here. It's not in line with anything. So again, this is an invalid experiment. It doesn't represent true eye level in any way.
Let's see the other two photos from that water level you had. This is damn near close sea level, and the water in the level is at sea level. Here we are 1200 feet up, and there's an island under eye level. And here you're 5,600 feet up, and you have a mountain below sea level. The only way to have horizon at sea level is this.
All right. But what is cool to look at is this one, for example.
Now, I'm not a pilot or an expert on planes, so I'm just going to switch this over to Wolfie. But in this video, we can see clearly that the HUD is following the eye of the pilot. This is way beyond both Phuket and myself, so I'm just going to pass this over to Wolfie. I'm going to link his video in the description. Well done. To end this video, Phuket word. You said something about do things by yourself, and this is my folder so far by stuff I've done and observed and experimented myself. Very much of it is photography and eye level exposure and many other stuff. So if you feel I'm wrong at something, please let's debate about it. I'm ready. Just tell me where I'm wrong in my video, and we'll find a channel and discuss it. And for those of you who are going to debate someone and are in lack of some observations, please let me know. I have a lot. This is just a part of it. And I'm more than willing to share what I got. Because as myself and a few others, there is no... not always we can get out the door and do stuff. So please let me know. I'm at your disposal. Thank you so much for watching, everybody. See you next time. Bye-bye.